the most basic thing we talk about computing, and that is programming languages. So we have found out that when it comes to mathematical computations, there are many programming languages that are available. But the dilemma of people is that which one to use, which one is more efficient, which one is better, which one is simpler. So today we are going to bring all these aspects into consideration, and we are going to talk about several programming languages. We are going to talk about the popular programming languages that are there. We are not going to consider we're not going to consider the very basic, the very unpopular ones, even though they might have great efficiency, but because their syntax and their languages might be difficult to learn. So we will be focusing just on the popular ones. So if any one of you can tell me a few names of the most popular programming languages, or the programming language that you prefer, if you can tell me, or if you want to write it down in the chat box, that will be great. Um, does anyone know about any programming language? Okay, no problem. Then I'm assuming we that our audience at present does not have much idea about programming languages. We'll talk about the famous programming languages that we have collected, and we'll present it to you. So I am handing this event over to Bhavesh, who will be talking about the first programming languages, and we are going to talk about its time complexities with high mathematical computational data sets and all of that, along with its syntax and what algorithm we're using to make you understand about all these things. We're going to do that. So over to Bhavesh.
Yeah, good evening, everyone. So now I'm going to start with this C. Let me share my screen. Is my screen visible?
Yes.
Yeah.
So before starting this programming, we have the brief intro to this C. So this is basically the historical development of the C. We all know the C language has been developed in 1972 by Denis Ritchie, but the seed to this language has been sown in 1960 itself by the international community. They have implemented the just basic things and named it as the algorithm language ALGOL. And in 1963, the Cambridge University has modified the somehow has came with some changes, and they named this language as the Combined Programming Language (CPL). And this, but the CPL is the very hard to learn and they implement. And the same Cambridge University modified and they reduced the complexity of the CPL and came with this TCPL. And again in 1970, AT&T Bell Labs, the Ken Thompson came with the B language, where the B language is somewhat similar to the C, but it fails in some of the situations in any mathematical problems like and some specific problems. After the verification of all those errors, the Denis Ritchie in 1972 has came with the C language, and the C in 1972 is just a plant, and it is evolved like now it's a big tree. In these few years itself, it's from the plant to the big tree. So this C, it's a basic language and is basic, and in keeping this language as a basic, Many languages came to existence like the C++, Java, JavaScript, and many more. And C is used for the embedded coding and legacy coding. It's a flexible language and it can be extendable. So why we need to know the C and what are its benefits? C has the many inbuilt functions and it offers the dynamic memory allocation. It's a structuring programming which has the functions, so we can break the complex programs into the simpler ones, and we can use the different functions to the complex codes as well. What makes C different from the other languages? Basically, the compiler of the C is much easier and it's most efficient. C is fast, and in terms of the execution time, it takes the less time to execute the code, and but it's the complex code. It has the low level accessibility. It's a good choice for level programming, and it is the only choice for the embedded programming. It performs it. C controls the microcontrollers in the embedded programming, which are very useful for the automotives, hardwares, and the today's world most trending robotics. So it's the only choice for the embedded programming. And it is also much useful to understand the fundamentals of the computer theories, like the computer architecture, compiler designing, operating system, etc. We really need the good knowledge in the C to know all these topics. And it's the only language we can know, we can understand the computer theories. So let me go with the coding part. Yeah, let me start with the simple program, array addition. So I have given a large data sets in my array. Is This is the array of size 1000 elements. I have stored the 1000 numbers in this array. So let me perform the average. So let me check the runtime, how much time it's take to execute the code. One second. Yeah, you can see here it's calculated the average for the sum of the element. We have performed the sum, and again the average we are getting the 5525.52, and the time taken for the execution of this code, it's like the 2000 microseconds, the 0.002 seconds it's taking the time to execute. Let me check with some better program which is little bit complex than the array addition. Yeah, factorial code. We know the factorial, how we calculate the factorial. In factorial equal to n into n minus 1 into n minus 2 into up to the 1. So this is the program in C for the factorial. We are going to check how much time it will take for the smaller numbers to run. So it's taking very negligibly, like we are seeing the 0 seconds. Actually, takes very negligibly. It's 700 to 800 microseconds. It's take the time to execute. So it's we are continuously saying 0 seconds, but it takes. Yeah, here we can see the 0.004. It's take very negligibly. It's take very less time to run for the very smaller data sets. Let's check with the larger data sets. We can see for if you try to implement for the 1000 factorial, it is showing me the 0, because the main reason for the on to get the error in the answer is we are the maximum size for a long unsigned integer is 20-digit storage. It can store up to the 20 digits. That's it. But 100 factorial, let me show it. Yeah, unsigned long for the integer types, the unsigned long can have the storage size of the 8 bytes, which is the 64-bit. It can store a maximum 20-digit number in it. Let me show you the 1000 factorial value. So this is the 1000 factorial value, which has 249 digits. So this is the reason why it shows the error. If you try to get the 1000 factorial has the 249 digits, but the long unsigned it can store up to the 20 digits alphabet. So we are good when we try to get the factorial for the large number. This code doesn't work. So this is an alternative code. This works for the large factor. And how its work is like, yeah, this is the code. We have the two functions, the factorial function and the multiply function. Here we are going to store the result in the array. So first moving to the factorial function, we are initializing integer array with result of the size max. This array will store individual numbers of our result in each of its array position. Like, let me show you the example. If you want to get the 4 factorial, it will store in the 2 and 4 in the array. The each individual number of our result will get stored in each array position. So in each array box size is the integer. It can store up to the 4. It has the size of the 4 bytes. So it's very easy for it to store the large data in the form of array. So we can get factorial for the large numbers also. Here we are initializing the first array position with the 1. Res of 0 is equal to 1. And as we are also initializing the result size with 1. Because 1 is the minimum result for any of the factorial, and it's the ending 1 into the 1. Now going to the for loop. For x is equal to 2, we are updating the result size from the output we are getting from the multiply function. So let's check what the output we are getting from the multiply function. In the multiply function, we are initializing the carry with 0, and for I equal to 0, I less than resize. Result size, initially we have the 1. So here I less than 1. I plus product equal to res of I into x plus carry. Res of I is 0. Res of 0 is 1. 1 into x is 2. 1 into 2 plus carry. 1 into 2 plus 0, it's 2. So product will be 2. Resolve 0. We are updating the first array position with product modulo 10. So 2 modulo 10 will be 2. So 2. And carry, we are updating the carry with the product by 10. 2 by 10, it will be 0 itself. While 0, carry is 0, so its while loop doesn't run. Return result size. Result size is 1, so we are going to return here 1. If we take the n as 2, the for loop will stops and will go to the next step. I is equal to result of size 1 minus 1, 0. I greater than or equal to 0, I minus minus. We're going to print the answer for the 2 factorial. So res of I is 0, so res of 0, we are going to get the result as 2. So 2 factorial is 2. So we have got, if the I is 3, again we are going to enter to the multiply function. Again we are checking the updates. The carry is 0 initializing. Our result size is 1 itself. And we are going to update the product again. Res of I is initially 0. Res of 0 is 2. 2 into now x is 3. So 2 into 3, 6 plus carry is 0. So product will get updated to 6. And the carry 6 by 0, it will be 0 itself, while carry is 0, so while loop doesn't execute. And we're going to return the result size. Result size is 1. So here 1 minus 1 again 0, and we are going to print the first array, which we have resolve. Wait. Here we are getting updated. Sorry. Yeah, I equal to 0. So product modulo 10 means the 6 modulo 10, it will be 6. So here also we are getting that. So we are going to get the result 24. For the third iteration, in the same way, now the product is 6, right? 6. I equal to 0, res size is 1 itself. Res of 0, now it's 6. 6 into, now x will be 4. 6 into 4, 24 plus 0. 24 modulo 10, rest of 0 we are going to update with 4. 4 carry equal to 24 by 10. Now its carry will be 2. 24 by 10 will be 2. While carry is 2, so we'll enter into the while loop. Rest of resize value is 1. So rest of 1 equal to carry modulo 10. 2 modulo 10, 2. Rest of 1 will be 2. We will update the result size with plus 1. So it will be 2. We are going to return the size. Now resize will be 2 minus 1, 1. For I equal to 1, we are going to first print res of 1, which means 2. Again I minus minus. Again we are going to print res of 0, 4. Now we have got 4 factorial 24. This is the basic working of this function. So here we are storing each and every number of our answer in the each array position. That's the reason we can even get the answer for the large values. Let's check here. Yeah. It's getting stuck again. So sorry. Factorial, yeah. Yeah, here we can see the 10 factorial value we are getting, and the time taken is 0.007 seconds. Let me check with the larger number, like say 1000. So I need to say right. Yeah. So we can see for the larger number, it's taking 0.1990 seconds, but for the smaller number, it is taking 0.007 seconds. If the time taken to run increases with the number increases, it's directly proportional. If you now increase the number, the time taken to run the program will get increased. If you take the 100 factorial, yeah, it's reduced. It's, see, we can see 1000 factorial, it is taking time is 0.199. 100 factorial, it is taking 0.008 seconds. It means the number, if you increase the number, the time taken to run the program will get increases. Now let me go with the third correlation code. Yeah, this is the correlation code. Here I have the to have the data of thousand numbers for the X and Y is a large data set. Let we change. Okay. Yeah, here we can see it's we are storing in the array X the 1000 numbers and in array Y 1000 numbers. Let me get the correlation coefficient for this large data set. It's taking very less time. 0 seconds. Yeah, here we can see 0.005. It's take very less time to run. We can say on an average the 4000 to 3000 microseconds. It's take very less time even for the large data sets to run in C programming. If we try to run it for the small data sets, for the large data sets itself, we are getting the very negligible time. And I hope for the shorter data sets, we cannot even, it's the 0 seconds itself. Yeah, 0.007. Here we can see the time taken. Here we can see the time taken 0.005. For the larger data set, 0.008. It's not much difference, only the 3000 microseconds, 2000 to 3000 microseconds, the time difference it's getting for the smaller and the larger data sets. And why we have to Yeah, these are the three programs, and now I hand over the section to Chetan. Hello, Chetan.
Yeah, I'm here. Am I audible?
Yes.
Yeah, just give me a second. Uh, is my screen visible?
Yes, it is.
Cool. Okay. The presentation is visible, right?
Yes.
Okay. Good evening, everyone. I'm Chetan. So today, now I'm going to talk about Java. So Java, as we have heard, we might have heard, it was actually created by a person called this guy who's James Gosling. He worked at Sun Microsystems, and Java was actually first called Oak, which it was just named because this guy had oak tree in front of his home. Later in 2009, Oracle took over Sun Microsystems, and Java is now under Oracle. Um, and advantage of Java is it is actually platform independent. It can run in it runs in any it is it is portable basically. Like languages like C one if you port from one computer to other, it may run or may not run. But Java does run because of this concept of bytecode. It creates a neutral kind of a file which can run in any machine, and each machine will have its own Java virtual machine. So this is how this is the advantage of Java, and Java is object oriented, which helps us to create uh, you can create your own data structures to do complex mathematical operations also. um, and it's fast, it is high perform, and it is very simple, and it's very secure too. And Java is actually built on C++. um, it is a high level programming language, and Java has many applications. You can do web development, you can create web applications, you can do app development. It can also do big data. You can create console applications, and you can even do game development. There are few frameworks like Spring and Hibernate in Java. There are many other frameworks. These are just few of them. Frameworks are basically things to make your job easier. So yeah, this is the introduction of Java language, and let's try to run the same programs that Bhavesh has run in Java. Okay, I hope my screen is visible now, right?
Yes.
Okay, so as Bhavesh has run, first let's do an average. So it's a simple average, you just sum and divide it by the length. And yeah, so here's the average. Just give me a minute. Okay, so I'm running my program. Now we can see here the average is 5052.412, and the time taken is 8 to the power 10 to the power minus 6 seconds. It's very low. Now, and now let's do the factorial. Now first let's try factorial of 10. Okay. Now we see that factorial of 10 is being calculated properly, and it takes approximately 10 to the power minus 6 seconds. Okay, now let's try for 100 factorial, and we run into the same problem as C. It doesn't calculate the right answer. Again, this is the same reason because basically, even if you use long, which is the the biggest amount of data that a single variable Java can have, you still cannot calculate even 100 factorial. Forget about 1000 factorial. So this is a problem with Java, which can be handled with other programming languages. Um, So now let's calculate the correlation coefficient. Okay, this, yeah. Now this is the correlation coefficient, and it calculates the same answer. And use the same formula that we have learned in statistics to calculate the correlation coefficient. So now compared to C, we have seen that the main advantage of Java is that it is actually object-oriented programming language, and you can do many things like web development and app development in Java. And Java is an open source, so you have a huge set of libraries, which are given by general public also. So this is the main advantage of Java. It has a lot of frameworks which make your things easier, and it is obviously a high-end language, so it gives you a high level of abstraction. And again, as I was told, because of the object-oriented concepts, you can do complex mathematical things by creating your own structures, data structures, and you can run complex algorithms too. So yeah, this is all about Java. Yeah. Now I hand over to Arjun, who's going to talk about Python. Okay. Yeah, Arjun.
Uh, Thank you, Chetan. I hope all of you are following whatever we are trying to explain with respect to time complexity in C and Java as of yet. So now we are going to talk about Python. I hope that my screen is visible.
Yes, yes, Arjun.
Um, uh, I know that Python is very famous, very popular, even among our audience right now. Many of you must be using Python as a language for say the popular domains of computer science like artificial intelligence, machine learning, data analytics. Python is the most popular one. It's in demand in this industry right now. Now let us know that why is Python so much in demand. um, Before that, we'll just talk about history of Python. So Python laid its foundation in the late 1980s, and its implementation was started in 1989 by Guido van Rossum in Netherlands. And by 1991, Mr. Guido, he was able to publish the code. And so that is how in 1991 Python laid its foundations, actual foundation in the world of coding. Very soon after that, in 1994, a new version of Python was released. It is just like changes that was made in C, as Bhavesh talked about. So Python 1 released a very important key features that was actually not a part of, I would say, any other programming language during that time. And the most important feature of that was the lambda function. Now, any good Python programmer will definitely know about lambda function. If you have to make any of that functional changes, you usually go ahead with lambda, and lambda function is still used today, even when we are at Python 3 we are at Python 3. So after Python 1, when Python 2 came, there also very important features were added, such as list comprehensions. And I think it was in Python 2.0 when the famous Tim sort was added as the default inbuilt list sorting function. So if you don't know about Tim sort is actually a hybrid sort of I guess merge sort and insertion sort. So it's a hybrid sort, and it has a great time complexity, and it is very fast. Sorting of the list is very easy. It's very easily done in Python. You don't have to learn a separate sorting algorithm for if in case you want to use a Python. So that makes things easier for suppose competitive coding perspective and all of that. And later in 2008, Python 3 was released. It is the latest one as well. Like it comes like Python 3.1, 3.2, 3.4, something like that. It releases, and new features keep on getting added. And much like Java, Python is also object oriented. So you can make your own uh, data structures, and you can work on that. So ABC programming language is said to be the predecessor of Python. That means before 1989. And a lot of the interfacing and handling was taken from the two languages that I've mentioned, that is ABC and Modular 3. So what are the benefits of Python? Why would you choose Python over any other language, right? So here are the reasons. Python is a supportive language to a programmer. It is user friendly. Its syntax is very simple. One thing, if you might have noticed in Bhavesh and Chetan's PPT or their environment where they were coding, is that there were huge coding that was done. All right. But when I show you in my Python IDE, you'll see that the maximum space that has been taken is by that array. That array is taking the maximum part. Apart from that actual coding that is there, it does not take. It's all like one liner or two liner. So it is user friendly, and maybe that is the reason why many big platforms and in today's industry, Python is it's a skill, and it's very easy to work. It's readable because its syntax is very user friendly, and it has a vast collection of libraries. Now Python libraries are very strong, they're very powerful. um, uh, they you can use these inbuilt libraries, and things get even easier when it is already easy, and things get even easier. So that's like an advantage above an advantage, right? And it's very easy to learn. If you do not wish to understand the complex syntax of Java and C, you can always go ahead with Python. But the only thing I would say about Python is that it is a slow language when compared to Java and C. It is going to work slow, and the reason might lie in its syntax, maybe because if you ever declare a variable as an integer value in C, you're actually explicitly saying that this variable is of integer type. Or um, uh, we saw that long unsigned int in Bhavesh's VS Code, right? So here we don't have to do that. Here Python itself understands by having a look at the value, and it assigns integer value to it. So that procedure takes up a little bit more time. Like, it is negligible. Because even when now that I'm going to show you my PyCharm codes, there also you will see that I won't be able to show you actual timings, because it is very fast. It is very fast, but on a comparative note, it is slow. So the environment that I'm using is PyCharm, and if you see, there is one library that I've imported, that is time, in order to find out the time, or how much time is it taken. And as I told you, the maximum part of my code is taken up by the array that I've taken, 1,000 numbers that are there. And here I'm just saying start. This line is for starting the time. This is just for this line. This is just one liner for printing the entire average. And this is like how much of a time it takes. You have to end that, right? So in Python, start time can be from any arbitrary number, and end time will end when just after the execution is done. of that particular lines of code that is between start and end. So we are just going to print end minus start, and we're going to get the value. So for average, don't think I'll be able to show you, but let's check out. Yes, so the first one is the average. The average is coming 5052. That is the same thing with C and Java that we were getting. And the time that they're showing is zero point 0.0. So even the time library that we have over here is not able to efficiently calculate the amount of time that was required to find the sum, find the average of this big array, right? So you might not have to worry that much, because if you're thinking about competitive mathematical coding or with that perspective, then you're still safe. Do not go by the saying that Python is a slow language and all of that, because even with a thousand numbers, it is quite efficient. That time library is not even able to figure out the time that was taken. All right. So this was about the average, the time that will be taken to find average of 1,000 numbers. The next one is going to be factorial. And if you see, I can, as I said, that this is looking like half code, but trust me, it is not. It is the entire code you need to find out um, factorial. So here also I've done that same thing. I have imported time library, and then I have started the time, and then I've defined a function wherein I have defined factorial function. It's there. It's a recursive function, and then I've just taken number as 10 to begin with, and after it prints, I'm ending the time. So let's check what happens. So for 10, again, it is zero point 0, and it is being executed. It is the same as C and Java. It was 10 was 10 factorial was getting executed, right? So now let me make it 100 and run again. So 100, I think it was not being executed in Java, but it is getting executed in Python, because I think Python is strong enough to interpret to keep this big of a number, right? But still, it is taking so less time that time library is not able to figure it out. And b- so you can see that Python as of yet is better than Java with this thing. Now let me make it even more difficult for Python, and let me try to take 1,000 factorial, and let's see if it gives me an error or if it executes. It gives me an error. So it won't be able to give, because I think there are more numbers than it can actually perform with. And I think the closest number that it can find a factorial of is 990 or something. Let's check out 990. Yeah, so 990 is executing, and here you can see that 990 is taking a lot of time, worthy enough time for time library to understand. So that is 0.0099 seconds over here, right? And the factorial of 990 is like huge number. So that is the closest that we have been able to that Python has been able to come. Okay. And the last question was related to correlation. So we are going to go to correlation now. And so I had to import another library that is called math. So if you ever want to do any mathematical, like if you want to do square root or logarithm or something like that, you can just go ahead and import the math library, and you can work on that. And then I have defined a function to find out the correlation coefficient, which is hardly 15 lines of code, and there is one while loop involved in it. And again, the x and y are going to take the maximum part of my code. So x is having 1,000 values, and y is again having 1,000 values. And then I've taken start time and end time. Uh, So and then I've taken a length of x, which I know for now it's 1,000, and then I'm just printing it, and then I'm going to end time. Right, so let's check if we can find a worthwhile time, because Python is slow, right? So we might be able to figure out a time. Yeah, so we are getting correlation as minus 0.004, same as what Bhavesh and Chetan was able to find out. And here the time is also, so with respect to Java and C, where you were still not able to find correlation, this program's value, Python you can find out, because again Python is slow, right? So 0.001 second, the time library was able to find out. So, with respect to syntax, I would say it's very easy. It's very simple. Most of my lines of coding was just about the array, and it is very minimal. If you see, it is very user friendly. You might be able to understand almost everything, and it is easy to it is easy to understand and write as well, right? And it saves time maybe over there. So this is all that we have to talk about with respect to Python. We will be going on to the next programming language, which will be taken by Bhavesh.
Yeah, so let me share my screen. I'm presenting, right? Hello.
Yes.
Yeah. Here we have seen the C, Python, and Java, how they have worked. And now we are entering to the C++. Let's see the basic intro to the C++. Here is the C++ development timeline, how the C has evolved from the 1979, the first it has invented, to the 2017, how it has evolved. These are the developments year by year we can see for the C++. C++ is developed by the B. Jare Stroutrup. He developed C++ from the AT&T Bell Laboratories, from where the C also they developed. C++ is basically the extension to the C. We can say C++ as a superset for the C. Also, it's like C plus oops. C++ can be defined as the C plus object-oriented programming. In comparison to the C, C++ has the additional things like the classes, inheritance, polymorphism, etc. So what's the benefits with this C++? C++ is has many benefits and it can be used in the game developments widely. It's a highly portable language, which is a choice of for multiple devices, multi-platform app development. It has the rich libraries. It has the many more libraries when compared to the C. It is very powerful, efficient, and the fast language. It is very similar to the C, and the speed will be also most likely comparable with this C. So let me go to the programs. Again, we are going to see the array addition. We are going to perform the average for the array addition. So have declare the size of the array as the 5 and have the smaller data set here with with my array size a as 5. I'm going to perform the sum and get calculate the average here. So when I run my program, so we are getting the average as the 3, and we are getting the time as very 0 microseconds. It's very negligible time. It's taking very less time to run. Let me check 2 more times. Yeah, now we are getting this 7,999 microseconds. It's basically the time code which is here is not works well all the times. So we need to run to 4 to 5 times. So we can see for the smaller data set, the time taken for average calculation is this 7,999 microseconds. We can see. Let me check for the larger data set. Here I have a number, 1,000 numbers. Let me copy and paste it. So now my array has the 1,000 numbers. It's the size of 1,000. I have changed it. Let me save this. And if you run now, it's taking much time. We are continuously seeing, yeah. Now I got the time taken is 7,990. In C++, we can see here. For the smaller data set as 2, we have got the 7,999 microseconds. For the larger data set 2, we have got the 7,999 microseconds. It is because the average calculation involved here is not very much complex. So for any of the data you are going to give, whether it may be the small data set or the larger data set, for the small complex codes, C++ will show the same, will give us the output in the same time with some slight changes. If we move to little bit complex code, if we go to the factorial code, here we are going to perform the factorial as we performed before. So first we learn with the small number 10. Yeah, here we can see we are getting the 10 factorial, and the time taken to run this is the 8,092 microseconds, which means 0.008 seconds. If you try to get the factorial for 1,000, we won't get it. We will get the wrong answer, 0. This is because we have already discussed the unsigned long integer. Let me go to the 50. For the integer types, for the performing factorial, we only need the integer data types. In all of these integer data types, the largest storage value we are having is for unsigned long integer. It can store up to the 8 bytes, and it can store a 20-digit number in it. It's the maximum extent for an integer data type unsigned long, which is the biggest storage. It can only store the 20-digit number, but we are trying to get the result of 1,000 factorial, which we have already seen, which has the 2,568 digits. But our data type can store up to the 20 digits itself. So we are going to have with the wrong results. To modify this, we are going to perform the other function where we will store the each and every number of our result in the corresponding array. Here we have the result array. So we are going to store if we perform the 4 factorial, we will have the 2 and 4 as our numbers of the result. We will get the 24 as result. So 2 and 4 will get stored in the array. Here we will not have any size complexities, as each number is going to get settled in corresponding array position. So here we can perform for the larger numbers as well. Yeah, if you perform 1000 factorial here, we can get the correct answer. Yeah, we can see here factorial for the 1000 we are getting correctly in this code, and the time taken is 19,708 microseconds. Here 16,000. It is like on an average we can say 0.01 second 17 seconds it is taking to execute for the larger data. But if we perform for the small number, yeah, yeah, we have seen here, right? If you try to perform 10 factorial, it is taking just 8,092 microseconds in the C++. But if you try to perform for the 1000 factorial, it is taking the time of 16,979 microseconds, which is the double. So if you try to increase your number, the time taken to run will get increased if we move for the moderate code complexity in C++. But for the array addition, we have seen if you even increase the size, if you even increase the number of numbers in the array, we have seen the same time taken to run. But for the moderate complex codes, C++, we have seen the different times for the data we have given. For the lower data, for the least number, we are getting the less time, and the more data, we are getting the more time. Moving to the correlation. In the correlation, I have the data with the 1000 elements. I have two arrays with 1000. I'm going to perform the correlation coefficient. Yeah, if you perform the correlation coefficient, we are getting the value as minus 0.004, and the time taken is approximately 8,495 and again 8,006. It's nearer to the 8,300, 400 on an average. It's taking time to run 8,300 microseconds on an average. But if you try to perform the same for the smaller data, now we can see. If you try to perform for the small data, yeah. If you try to perform for the small data, we are getting only the 2074 microseconds, but for the larger data, we are getting 8,000 microseconds, which is the 4 times. We have seen for the smaller, for if the code complexity in the C++ is small, we have seen the time never changes for the smaller and the larger data sets. It's giving the same time. But for the moderate complex codes in C++, we have seen for the smaller data sets, we have getting the time which is half for the larger data sets. The time taken to run is double for the larger data sets in the moderate complex codes. For the large complex codes in the C++, we have seen the smaller data set is taking just a 2000 microseconds, but the larger data set is taking 8000 microseconds, which is the 4 times. Here we have seen into 1, here we have seen into 2, here we have seen into 4. If we, it depends on the code complexity. The smaller and the larger data sets going to take different times. And why this C++? C++ is what makes C++ different from other languages is its object-oriented programming, which includes the inheritance, polymorphism, all this. This all makes the C++ little bit different from the other programming languages. In the terms of the code, in terms of the runtime, it's very similar to the C. And we can see here a table for that. It's a standard table for energy, time, and MBIF of different programming languages. We can see here C, Rust, and C++. These are the languages which takes the less time to get executed. And C and C++ will take the execution time different from different compilers. Like here we have seen in Visual Code, it's all in microseconds, it's 0.002 seconds. But if I perform this same in this dev C++, I can see 0.3991 second, 0.36 seconds. But in Visual Code, we are seeing 0.008 seconds, 0.004 seconds, like that. The compilation time for C and C++ changes with the compilers we use. So that's all. Now I'm going to hand over session to Chetan.
Hello. Yes. Is my screen visible now?
Yes.
Yeah. Okay. Cool. Now coming to JavaScript. So anyone of you who have tried web development must have definitely heard about JavaScript, because JavaScript is the language that actually gives um, logic to a website. A static website becomes more interactive and more logical because of JavaScript. It's like the brain of a website. In fact, it's even used for app development. So this guy, Braden Each, is the one who actually developed JavaScript. He worked at Netscape. So JavaScript, actually, the need of JavaScript was because once upon a time when there was a time when websites were so bad that when you had to perform a logic, say get search results, or when you click something, something has to happen. That wasn't possible because every request that you give had to go to the servers of the company, which were in long distance places, and it had to run there, and then it had to send back the response, and then it should be displayed on your browser. So those are the times without JavaScript. Very horrible. You cannot even imagine being having this kind of so much opportunities in web dev without in those kind of conditions. And then this guy called Brendan Each actually made JavaScript just in 10 days, and it's amazing. And it is a very powerful language, JavaScript. And one thing, wild misconception is JavaScript. They sound similar, so they are similar, but no. JavaScript and Java are completely two different entities. Though Netscape worked with Sun Microsystems to develop JavaScript, they're not the same. They're completely different, literally different. So the reason JavaScript is named JavaScript is because the name Java was so popular then. So that's the reason there is no similarity. Now JavaScript is again object oriented, and it is versatile because there are huge applications in JavaScript. Again, it's platform independent, and again, less server interaction. This is the main reason. You can run the logic in your browser itself. When you send a website, the logic is run in your browser, so there's a lot of time saved in sending your request and getting the response. So the syntax again, like Arjun has told about Python, JavaScript syntax is also very easy to understand, and it is very easy to implement, and it is efficient. So now, again, as I told you, it is used in web development, it is used in app development, it is used in game development, and it is used both in front end and back end. Front end is the things that you see, the designs, the placements, and everything. And the backend is the the server side where the data is handled, where the requests are handled, and all the stuff. And gaming too. So there are libraries like Express and npm. Npm is basically a repository of many libraries for Java. This is called React and native React, which is used for AppDev and WebDev too. And Node.js is basically a way to run JavaScript in your local device. So it is very powerful JavaScript. So now you can create simple games. Like this is one of the simple JavaScript code that I coded, and it is very simple. This can be done in JavaScript. At the same time, this game is also coded using just JavaScript. You see how powerful it is. It is so this is the advantage of JavaScript. Now, coming to the coding, the mathematical part, you can see this is the logic. This is the code that I have written. So same as other codes, the average, factorial, and correlation. So first, let's try to calculate average of this huge array, the same array used for all the other languages. So again, same as Python, I have used the same logic. I've written this function for average, and then here I've done this thing same as time.time in Python. There is something called window.performance.now. This window is actually again imported from this library called JSDOM. Okay, so I calculate the average, and before that I just start the time. This basically calculates the time over there and time end. Again, when it's the same thing, again when you call this function, it calculates time over here. So between both of these times, you have this function call. So when I do end minus start, I actually get the time taken, and I've actually run this 1,000 times, and I've taken the average of that. So now let's see how does this do. So actually running this. This is basically using Node that I've just told. I'm running JavaScript in my local system. So you can see that it takes 0.0001 second, and this is the average. This is you can run it multiple times. You can get a little bit variation. But the average is approximately 0.0015 or 6. Okay, it is still very less. Okay, now let's try for a little bit smaller data sets. Okay, let's say some 5, 6. So now you see the time is similar, but yeah, it is similar, but you can this is because as same as Bhavesh told, this is not similar. Sorry, you have an extra 0, so it takes much lower time than this. And again, if this is a very simple algorithm, so you do not see much difference. Same as Bhavesh told, because it's a not very complex algorithm, you don't see much difference. So now let's try for factorial. The factorial code that we're using is the recursion code that most of you might be familiar with. So now let's run the factorial. The factorial that we are running now is 10 factorial. Let's try it out. So yeah, you can see it's again taking 0.000001. Okay, so sorry, I think okay. Yeah. So now you see you got the 10 factorial. This is the correct one. So yeah, you run again, approximately the same answer. So you see now let's try for 100 factorial. I hope it comes. Okay, you get 100 factorial. So this actually means 10 to the power 157. So you see, as Python, you don't get uh, such correct answers in such. I mean, no, what do you say? You don't get the you get approximations in uh, JS actually. So you see the runtime, it's actually increased slightly, but it did increase. So uh, this is now, let's try for 1000 factorial. It won't work. So it actually gives infinity. Okay. This actually means that okay, I cannot calculate more than this. So the biggest number that I found out that it can calculate is 170. Okay, so you get the answer. Still, it is still you don't get the full answer. So the main problem with JavaScript is it is not very mathematically efficient. But you can do things like you can import modules like uh, something called this map.js, and maybe you can there may be other algorithms that have been written by other people that you can use. But in general, JavaScript is not very mathematically efficient because it's not basically used for a lot of maths. So yeah, now let's just try the correlation with this huge data sets. Uh, you see the answer is, you get the correct answer. The time is very low. It's very low. So yeah, if you try for smaller data sets, you see it runs much faster. So I get the answer correctly. So this is about the coding part of JavaScript. You see that compared to C++, coming to obviously we've seen that there's been, you have these approximations and all those things. JavaScript is not very efficient for maths, but JavaScript is actually very powerful due to its due to its place in web development. It is so huge that it's a king of web development. Most of the websites like are the most famous websites like YouTube, Google, Facebook, all of them work on JavaScript. You can see that I can go to any website like let's just see it on GitHub, for example, and you inspect it, and you see this tag called script over here. You see this thing is JavaScript. So almost every website you can check has this thing called script. So this is the power of JavaScript. It is almost used everywhere in web development and in app development too. So if you are interested in more of web development, app development, and front end and back end works, JavaScript is the thing that you must learn. And it is similar to Python. It has a lot of open source libraries that you can do from you can get from npm. So though it's not so much rich as Python, still it has a huge set of libraries which using which you can perform many operations in web development. So yeah, this is it about JavaScript. So I hand over to Arjun for the vote of thanks.
I hope all of you have tried to understand whatever we were trying to express to all of you. So here is the comparison of all the famous programming languages, and now it's all up to you to decide and choose whichever one you feel was the best among these programming languages for your mathematical computation. With this, we come to the end of today's event. I would like to express sincere gratitude to everyone who is present here, and thank you for patiently listening to our event. Thank you once again on behalf of the entire Vitmas. Thank you.